Assalamu alaikum dear students, and welcome you all for today's science class. Let's start with the talk of the day. And today's talk of the day is go up and never stop. It means that in life, whatever obstacles and problems you face, you shouldn't stop trying. You shouldn't give up, right? You shouldn't lose hope. What you should do, that you must keep your spirits high and face the challenges of life without losing hope. Right? Just trust in Allah Almighty and keep on going high with your positive attitude and full determination to get success. Clear? Okay, as you know, we were discussing about metals. And do you know the story of using metals is also written in Quran? Allah has sent many prophets to preach Islam, and Hazrat Daud alayhi salam was one of them. Hazrat Daud alayhi salam was given wisdom, understanding, and knowledge about what to do and how to do. Clear? And he always did good deeds and beneficial deeds for mankind. He worked on metals, he processed iron metals, softened them, and made battle dress to protect their people from intensity of war and to protect them from their enemies. So, the story of metals is very old. People have been using metals since long. Do you remember what properties we had discussed in our previous class? In previous class, we had discussed that metals are hard and shiny. They show lustrous appearance also. Metals are sonorous, which means they produce deep ringing sound when hit. And metals, they have high melting and boiling point. Means metals, they do not melt or boil easily. Right? So let's move ahead towards second part of properties of metals. So today we will discuss another property of metals, that is metals conduct electricity and heat. Right? Metals are good conductors of heat and electricity. That is, it allows heat and electricity to pass through it easily. To understand this property of metals, students, you have to recall the structure of metal. As you know, in metals, atoms are tightly packed. Atoms are tightly packed and are arranged in a regular layer arrangement. And in metal atoms, there are only few valence electrons, right? Valence electrons means electrons in the outermost shell. So in metal atoms, maybe there are 1 or 2 valence electrons in their outermost shell. That's why these atoms, they are desperate. These atoms having valence electrons, few valence electrons, they are desperate to lose or give away their valence electrons to become stable. So as soon as valence electron leaves its shell, this yellow part where I am flashing the light is the valence electron, right? As soon as the valence electron leaves its shell, nucleus of that atom, this bigger circle, the nucleus of that atom gains positive charge after losing the electron and become positive ion. And the valence electron, the electron which was present in the outermost shell of that atom, has negative charge on it and it becomes free now. These are all valence electrons. They are free now, right? And they start moving, all these valence electrons, after leaving the outermost shell, they start moving around all the positive ions present in the metallic structure, as you are seeing in this picture. These free electrons move fastly and randomly around the positive ions like this. They are moving fastly and randomly around all the positive ions. Now these free electrons, they move only inside the metallic structure, right? They never go outside the metallic structure. Why? Because there is a force of attraction between these free electrons and the positive ion, which hold them together inside the structure. And that force of attraction is called metallic bond, right? That force of attraction is called metallic bond. Metals or metal atoms, they are held strongly to each other because of this metallic bond, right? And this metallic bond, it is present. It is the force of attraction present between the electron and the positive ions. These free electrons, they make C, all the atoms, around all the atoms in a metal by moving randomly and fastly, right? These free electrons, they make C around all the atoms, all the positive ions in a metal by moving randomly and fastly, right? Just like blades of a fan moving rapidly when you switch it on. Clear? Concept of metallic bond was first given by a German physicist, Paul Drude, in 1900. And this model is known as free electron model, right? This model is known as free electron model, in which free electrons, they are randomly and fastly moving around all positive ions. These free electrons, they do not only move around one atom, but they keep on moving around all the atoms present in the metallic structure. They keep on moving around all the atoms present in the metallic structure, as you are seeing in the picture. And that's why these free of electrons, they are called as sea of electrons, right? These free electrons are called as sea of electrons, right? Here, the meaning of the word sea of electrons is constant flow of the electrons. As you are seeing in this slide, that these free electrons, they are constantly moving around all the positive ions. That's why we use these words, sea of electrons. Sea of electrons means constant flow of electrons. Clear? Okay. Now moving towards this next slide. It is basically a video clip. I will show you that how these free electrons, they move randomly around all the positive ions and how they conduct electricity. When one atom gives away its valence electrons, then it moves and go to the next atom. The next atom throws is away. So in this way, this free electron keeps on moving, jumping and bumping moving from one to another atom, forming C like this. And the same happens with all the free electrons present in the metallic structure. One more thing I want to tell you here, that these free electrons, they are also called delocalized electrons, right? These free electrons, they are also called delocalized electrons. Delocalized means removed from particular place or location. Removed from a particular place or location. That's why these electrons, after leaving the outermost shell of the atom, they are called free electrons, right? Because they are removed from their outermost shell, from their place, from their location. And now they are called free electrons. And they are also, we can also call them delocalized electrons. Clear? Now, after understanding the structure of the metal and about metallic bonding and the presence of free electrons, you will now see that, and you will easily know and learn that why and how these free electrons, they move, they conduct electricity. Clear? Okay. If let's wait for some time. Okay. If you see this video clip, in this video clip, you will see that if the voltage is applied to the metal atoms, right? Now you understand the exact structure of the metals. So if voltage is applied to metal atoms, then the free electrons, they gain energy, right? These free electrons, they gain energy, and they help, after gaining the energy, they weaken the bond. After gaining the energy, they weaken the bond present within the metal atoms, and they jump into the conduction band. You will see after some time that how these free electrons, after applying the voltage, they get the energy, they weaken the bonding, metallic bonding, and how they jump into the conduction band. These free electrons are moving around all the positive ions, and when the switch is on, see, the switch is on now. These free electrons, how they are moving, they are jumping into the conduction band, and this is how the current flows from the negative to the positive terminal, right? So now the switch is on. You can see what happened now. So basically, the electrons, they gain energy, which trigger their movement, making them shift from one to another end of the conductor, as you are seeing in this video. Clear? Okay, now moving towards the next property, that is electrons, they conduct heat also. As I have told you in the beginning, that the metals, they conduct electricity, and the metals, they conduct heat also. How the heat is conducted in the metals, we will see this property in detail. When heat is applied, if you see over here, when heat is applied, then the free electrons, they gain more energy, and they start moving faster, vibrate faster, start bumping and jumping into each other, knocking against each other, and moving through the conduction band, right? So in this way, metals, they conduct heat, right? When metal is heated, the free electrons, they gain energy, they gain kinetic energy. This means the free electrons, they move faster and transfer the energy from one atom to the other atom, then next atom, and then so on, through all the atoms present in the metal. This makes heat transfer in metals very efficient. In this way, metals conduct heat, or we can say that heat is transferred through metals easily through this way. See how heat is conducting quickly by the movement of free electrons, right? You see over here how the heat is conducting from the candle. Heat is conducting quickly by the movement of free electrons from one end to another end of the conductor. That's why metals are good conductors, right? Metals are also good heat conductors, right? In metallic structure, though metal atoms are packed more densely, more closely to each other, right? As you know that metal atoms in metallic structure, they are closely packed to each other. They are packed more densely, but still they can transmit heat vibrations more readily, right? As they are closely packed, so they can transmit heat vibrations more readily because they have free electrons in their metallic structure, right? They have free electrons which also help them to transmit heat vibrations more readily. So when a metal is heated, actually free electrons gain energy. Those delocalized electrons or free electrons which are present in metallic structure, they gain energy. And after gaining energy, they vibrate more quickly, right? And then they move around with greater speed. So this means that they can pass on the energy more quickly, right? So now we can say that there are two reasons for good conductivity of heat in metals. And what are those reasons? Number one, the close packing of metal atoms or metal ions in the metallic structure, right? The closely arranged metal atoms in the metallic structure is one of the reasons for good conductivity of heat in metals. And number two is the presence of free electrons, the presence of delocalized electrons in metallic structure. Because these free electrons which are present in metallic structure, they can carry energy through metal structure by moving faster, colliding with other atoms, as well as colliding with other free electrons, right? These free electrons, after gaining energy, when a metal is heated, these free electrons, they gain energy, and after gaining energy, these free electrons, they start moving faster. And they not only collide with other atoms present in the metallic structure, but they will also collide with other free electrons present in that metallic structure. So this naturally makes them vibrate faster. So heat is passed quickly through the metal in this way. Clear? That's why cooking utensils are made of mostly metals. You have seen in your kitchen, mostly the cooking utensils which are used for cooking food, they are made up of metals, right? We can cook food faster because of good conductivity of heat in metals, right? And secondly, if you observe an example of copper, copper wire is not only a good conductor of electricity, as you have seen that copper wires, they are used in electric cables, in electric wires, right? So copper is not only a good conductor of electricity, but it is a good conductor of heat also, right? It is a good conductor of heat also. This means that if you heat one end of a piece of copper, the other end will quickly reach the same temperature, right? So this shows that If you heat one end of copper, then the heat energy will transfer through these free electrons to the other end. So copper, it shows that it is also a good conductor of heat because it allows heat to pass through it quickly. Clear? So this is all for today's lesson. And what we have discussed so far, that metals are good conductors of heat and electricity because of the presence of free electrons in the metallic structure, which after gaining energy weaken the bonding within the metal atoms and jumps into the conduction band, right? How they are helpful in conducting heat and electricity, that when they gain energy, they weaken the bonding within the metal atoms, and these free electrons, they jump into conduction band. This is how they conduct electricity. Then I also told you the two reasons, the 2 points, which shows that the metals, they are good conductors of heat and electricity also. One reason I had told you that the closed packing of metal atoms in the metallic structure, it also helps in conductivity of metals. Second reason I have told you, the presence of free electrons or delocalized electrons, and the presence of free electrons also help in the conduction of heat and electricity easily, right? Okay, if you have any query regarding today's topic, you can ask now. It's time for question answer session, right? Are you ready for it? Now I will ask questions to check your understanding about what you have learned today. My first question is, do metals conduct heat and electricity? What is your idea? Can you explain? My second question is, describe the arrangement of electrons in a metal. My third question is, what are free electrons? My fourth question is, what is metallic bonding? My fifth question is, who gave the idea of metallic bonding? Do you remember the name of that person? My next question is, how does arrangement of electrons help a metal to conduct electricity? My next question is, how heat is conducted in metals? Okay, now it's time for homework. And what is your homework for today? You have to find out more information about free electron model through internet, right? It will help you to enhance your knowledge about this concept, and you will also enjoy reading about free electron model. So note down your homework. Okay, this is all for today's lesson. Goodbye from my side, and thank you all for watching and listening.